Okay, so again, what is a theoretical probability that an even number will be rolled on a number cube? Now hold up for a second. Number cube is just the dice, correct? It's got the numbers 1 through 6 on it, right? How many of them are even? How many of them are odd? So what's the probability of rolling an even? 3 out of, which reduces to. So now listen, I'm trying to just go through slowly with you. The theoretical probability of throwing an even is 1/2. Does everybody agree? But we did an experiment. So instead of saying the theoretical probability, we're going to write the experimental probability. That's it. That's the only difference. So you have to be able to read a chart. Now, can someone tell me what frequency means? Yeah, how many times it's happened. Good. You guys, this isn't easy for you. Frequency is the 1 was rolled how many times? 8. The 2 was rolled. There we go. Now look, you must stay with me the whole time. Some of you guys who are struggling a little bit, you got to come on. Now's the time. Speak up. Ask a question. Don't wait 5 minutes. Your daydreaming is causing problems. All right. Right now, we're learning something. All right. So it says, what is the theoretical probability? First of all, how many times did we throw the die? Well, you go to your table and you put underneath it total. Now, don't take his word for it. He said 36. Anybody else agree with that? So somebody else did the math too and said it was 36. Everybody agreeing?
Yeah.
All right. So we want to know the theoretical probability that he drew an even. So I'm going to make a fraction. I'm going to put a 36 down, and then I'm going to count the evens. Anybody else get 15? So that's the theoretical probability, 15 out of 36, but of course we're going to reduce that. 5/12. Now, I prefer that you not use a calculator right now. When you go home tonight, do I care about a calculator? No. All right, but you're practicing. We're practicing reducing of fractions. ERBs are coming up in 8 weeks or whatever, and we'd like to do well. All right, it's been a long time since I've said what's up with the fractions and reducing. All right, so you might forget on the ERBs, but you might know it also. That's why you're practicing. What? How many even numbers were rolled? 3, 9, and 6 is 15. That's what I said. 3, 6, and 6 is exactly what I said. I got it videoed right now. Do you see what I'm saying? It's 15. No, come on. What you even told me, what does frequency mean? Right. So how many 2s were rolled? How many 4s? And how many 6s? There you go, man. Clicked, right? You got it now. Now just add those up. How much is that, do you think? There you go. You good now, right?
Yeah.
That's the theoretical probability. All right. Now, right next to it, probability that you get an even. What should it be? What should it be? That's the theoretical probability. Come on, I'm trying to give me a, we talked about it already. What is it? 1/2. Thank you. Probability that you get even, the theoretical probability is 1/2, but we did an experiment. All right, we threw the dice. This is what we came up with, 5 out of 12. Is that too bad? Is that too far off? Yeah. No, not too far. All right, now number 2. Everybody read number 2. Write something down. Oh, guess what? What is the theoretical probability? So here we go. I'm not reading very well, right? Because I think I know what the question is, so I answer what I think the question is rather than just read the question, right? That causes me problems when I take tests. So this theoretical probability is 1/2. Does everybody agree? And then the next one was the what? Yes. All right. So sorry about that. We got to read carefully. All right. So is everybody happy with that being 5/12? For those of you guys who were not here yesterday, is everything going fine? All right, here we go. Because that is the experimental probability. I just didn't even read the question. You with me? I did not read the question. That's why I got it wrong. What should happen? What should happen? No, not the best guess. It's what should happen. All right. If you roll the dice, you're going to get an even number half the time. That's what should happen. That's not what happened when we did our experiment.
So theoretical is what should happen.
I couldn't have said it better myself.
And
experimental is what happened when you performed an experiment.
Okay.
All right. So let's take a look at number 3. All right. They're just trying to differentiate them. So the theoretically, if you roll a number cube 36 times, how many times would you expect it to roll the number 1?
6, because of 6 numbers and 6 times 6.
Is everybody with me? All right. So please, everybody put this on your paper. Because again, I know when you take standardized tests, this is a weakness. And I think it should be a what? I think it should be a strength. I don't think there's anything to it. All right. I know I haven't done it. I'm showing you. How many times would you expect to roll a 1 when you throw the dice?
8.
No. I want the theoretical. All right. So when you throw the dice, you're going to get a 1. How many times?
6.
I know that's not what I'm asking. Tell him. 1. Every time you roll the dice, 1/6 of the time, I need everybody to write that number down. 1/6 is my answer so far. That's the probability that you get a 1. I need you to write that down. You're going to start learning how to write in math. What does P of 1 mean? Probability that you roll a 1 is 1/6, correct? So 1/6 of the time. In math, we've said it over and over. What does of mean? Multiply. So he is correct. We're now going to do 1/6, and then we're going to multiply it by the number of times that you roll the dice. How many times did you roll the dice? 36 times. So you should get, theoretically, you should get how many again? 6. Theoretically, you should get 6. Now it says, how many times did you actually roll the number 1 in the
8.
experiment? 8. So is that a little bit high, do you think? Yeah, it's kind of high, but does it really matter in the grand scheme of things? No. All right. Come on now. This is what I'm talking about. All right. Write down the information. All right. If you don't know something, speak up right away.
So isn't it between 1 over 6 or is this 1/6?
I have no idea what you just said.
How did you get the 6 at the bottom?
1/6 times 36. What is 1/6 times 36? Yeah. How did I know that? Because it's just 36 divided by 6. Now, I'm glad you're asking me because it's a review of our what? Fractions. It's been a while since I've asked you what's 1/3 or what's 1/6 of 36. You're supposed to say to yourself, that just means 36 divided by 6. That's what that means. That's how I got the 6. Good? All right, I like your question. All right, here we go with number 5. What is the theoretical probability for rolling a number greater than 4? What would be the theoretical probability? No, what's the theory? Tell them. Why 2/6? 2 out of 6 are greater than 4. So I'd like everybody right now to write the probability, put P, is greater than 4. I don't care. That's what we got. What's the probability that you get a roll greater than 4? And the theoretical probability for that again is what? 2 out of 6, which we're going to go ahead and reduce to 1/3. Okay, so now what is the experimental probability? All right, I'm just going to put this right here. What does E stand for? Experimental probability is greater than 4. Everybody calculate that for me real quick. What is that? 10 over 36. And we're going to practice reducing.
5 over.
How many times does 2 go into 36? 18. Now, we're not using a calculator today. We're practicing our mental math. All right, if you don't know that's 18, remember, the quickest way to do 36 divided by 2. 2 goes into 3 one time with 1 left over. 2 goes into 16, 8. All right, that's how you should be doing it mentally. All right. Now it says, what is the difference between theoretical and experimental? All right, well, I mean, right here, they're just asking you, the theoretical was what? 1/3 minus the experimental, which was 5 out of 18. I think we're just doing 5 and 6, right?
Theoretical was 1/3.
You with me? Of course. Uh-oh, now we have to do this subtraction. Without a calculator. So what do I need to do? No, without a calculator. Tell me, Carolyn. Multiply 1/3 times 6. That is correct. Beautiful. So now you get 6 over 18 minus 5 over 18, which is what? Say that again. 6 minus 5 today. Shh. How did? Wow. All right, we'll let that one slide. 6 over 18. Anybody have any question? Now, again, please, I'm kidding. But anybody have any question with the fractions, guys? Come on now. I want you to take your ERBs. I want you to say, wow, they did great on their fractions. All right, I'm asking you, if you don't know, speak up. If you forgot how, let me know. All right, let's see who was paying attention. All right, so in question number 8, it says, if a car factory checks 360 cars and 8 of them have defects, how many will have defects out of 1,260? All right, it's called sampling. All right. How many out of the 360 had defects? 8. Do you think anything is going to change? Probably not, right? So 360 was the total in our sample. 8 was the defects, right? So what am I going to do? Ooh, actually, we're going to make a proportion. All right. But we can say, how many is the new total? Right. And we want to know what the defects are. So that goes X. You see that? And now we just cross multiply. All right. So 360X is equal to, now I don't care if you use your calculator on this. Somebody tell me what 8 times 1260 is. 10,080. And then when you divide, how much? So you're expecting 28 defects. Say it again. Is that right, guys? Did everybody do 1080 divided by 360?
What if you 1,260 divided by 360 and then multiply how many 360 go into 1,260?
Well, but is that the right answer? Try that on your calculator. See what I'm saying? That doesn't work. Do you agree?
Yeah.
Okay, now what I want everybody to do now is please listen up. Because what? I know, but you said do 1260 divided by 360. Is 1260 divided by 360 28? No, it's not, right? Then you have multiply by 8. That's the same as cross multiplying and dividing. You just did it out of order. You with me on that? Now, what I want everybody to do is take out your handy dandy calculator and tell me what 8 divided by 360 is. Right, 0.022. Now, is that correct? 0.022. Say it again.
0.02.
So it's like that, right?
Yeah.
Okay, so now take that number on your calculator and multiply that by 1260. And that's 28, right? Because I converted this, right? Is everybody okay with that? Does that make sense to everybody? All right. Now let's look at 9. If a car factory checks 320 cars and 12 of them have defects, how many of 560 will not have defects? So help me out with this, Quinn. What do I need to do? Uh-huh. 12 over 320. I know what you meant.
Oh, there we go. Okay, so 12 over 320.
And then
X over 560.
Beautiful. That's the way I would do that.
Then 12 times 320 is 3,800.
Wait. 12 times what?
12 times 560.
Yeah, slow down and get it right, buddy.
Equals 6,720.
And then what?
Then divide by 320
Uh-huh.
equals 21.
So 21 represents the number of defects, though.
Don't have. So
Right.
it's 5.
5 what?
539.
Well, good. 560 minus 21. 539. No defects. All right, guys, you got to help me if you don't know. 539 have no defects. Everybody good with that? All right, so here's now another good example, all right, of where we don't know the exact probability that your African violets will sprout. But we did an experiment and we have how many will sprout? No. But I'm saying, what is our experimental probability? I'm asking. Experimental probability would be what? Here's your experiment. Well, remember the denominator is the total. Yes. 9 over 30. So everybody agree with that? And that, believe it or not, it reduces to what? 3/10. Now, once you find your probability, you would just go ahead and multiply that by how many you actually did. You have 20 seeds. So how many of them would you expect to sprout? Yeah. 6 seeds. All right, let's everybody look at 11. Hopefully you're getting a little better. Sorry, it's not as exciting. All right, if you are picking a number between 1 and 20, what is the probability that you will pick a number greater than 14? How many numbers are greater than 14?
5.
5 or 6 now.
No,
Oh,
no,
five.
five.
Because you don't count 14.
Yeah, you don't count 14. All right. So 5 of them are greater than 14. And how many of them are less than 4?
3.
So how many altogether are fit that, right? So we would say 8 out of what? And then of course well, what numbers are greater than 14? So it's how many? Oh, she is right. Thank you, Miss Vaughn, for it's not 5, but what? 6. Right. Thank you, Miss Vaughn. So that's 9 out of 20. Does everybody agree with that? You have 9 out of 20 chances. All right. All right, let's take a look at 12 now. Ooh, now number 12 is a hard one. If you're picking a number between 1 and 20, what's the probability that you'll pick an even number or a multiple of 3? All right, I'm going to put it on pause just for a second. And I want everyone, let's see how you're thinking. So far, I have a 13 out of 20.
What question is it asking? It
I
says
don't know.
that you will pick an even number or a multiple of 3. They're asking us what's the probability that we'll pick an even number, or it's the probability that we'll pick a multiple of 3. So
Oh,
both combined.
all right. What did you get? 16 out of 20. I like it. What did you get? 10.3 out of 20. That's interesting. Shh. 16 out of 20. I got another 16 out of 20. What did you get? Oh, I like it. 3 out of 20. What? Liv, good for you. 17 out of 20. I like that. Go. Ooh, 16 out of 20. 8 out of 20. Go. Somebody else. 14 out of 20 is different. Anybody else with a different probability? Go. I like it. 4 out of 20. What else? 13 out of 20 is good. Go. 14. 16. 13. Just an answer. We don't need a statement. No, I just want a fraction. 4 out of 5. I like it. All right. Okay, so how many right answers are there? 1. Okay. Oh, I like that confidence. I like the confidence. So now just listen to me, please. Hey, come on. The problem here is that people generally are lazy. All right, that's why they can't do these. If you're not lazy, the problems are easy. Hey, so here we go. I'm going to put the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. No one's asking you anything. All right, those are all the numbers. Now, I need to pick a what? Even. So I take out my handy dandy highlighter and I say, okay, how many of them are even?
9.
10.
It's 1. It's
Shh, I'm not asking. I'm counting them. There's no reason to argue. All right, no reason to argue at all. We're just counting them up. Right? So far I counted 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 that are even. So 10 out of 20 so far, right? Now, I also need to be, or I could pick a multiple of 3. So now I'm going to take my handy dandy highlighter again, just to show you multiples of 3. 3, but didn't I already count that one? I already counted that. So 3, 6, 9, 12, 15, 18. So how many are those?
1, 2, 3.
How many are green? 6, right?
Didn't we already?
I'm just, come on, just let me go through it. I promise you I'm going to be right. And you're going to go, okay, that makes pretty good sense. All right. So how many of them were green that we highlighted? 6. But Davis, we did what? We counted some of the multiples of 6 are also what? Even. We already counted them. So how many of them did we count twice? 3. So we subtract out 3 out of 20. So those of you guys who said 13 out of 20, I'm proud of you. You were thinking about it. Shh, shh, shh. Don't celebrate. Miss Vaughn, what? But it says what? Or you have a choice. You can either be even, you can pick an even, or you can pick a multiple of 3. That's what they're telling you. You can pick an even or a multiple of 3. Now, here is what I would like for you to understand. All right, there is a formula for this. All right, I don't use the formula because it's a little hard to remember, but watch what the formula is. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A or B. Or I'm sorry, A and B. I don't want to put that. I want to put this down. A and B. Now, when you go to college or you take AP stats in high school, that's the formula you're going to use. All right. Do I care about that formula right now? I don't have to even remember that formula because I understand what I'm doing with probability. Probability of A would just be the probability of getting an even number. B means the probability of getting a multiple of 3. Probability of A and B is just the probability that they're both even and a multiple of 3. That's all that means. Now, if you were listening to me, I just tried to explain it. What? Yeah, I'm having trouble with my pen. Thank you for correcting me. You know how I love to be corrected. Good, good. We only have 2 minutes. That's perfectly fine. All right. That's the formula. You should write that down at the top. Do I expect you to memorize that and have that known? No, I don't care. I'm just saying that's a little bit more advanced. All right. That's a little bit more advanced.
So what's A and what in that?
What do you think A is? Let's do this.
The even
And what do you think B is?
multiple of 3.
Right. Event A, you're 100% correct. Event A is the probability of getting a what? Even. Event B is having a multiple of what? 3. All right. There's something called mutually exclusive we can talk about too, but we're not going to do that right now. There's lots of cool things I can show you about probability, but we're just kind of focusing on the basics. All right. Give me one more second, guys, then I'll reward your greatness today. All right. If you are picking a number between 1 and 20, what is the probability that you pick a multiple of 2? What's the probability of getting a 2? A multiple of 2. Tell me, you're right. 10 out of 20. So I want everybody to put 10 out of 20. Come on now, please pay attention. What's the probability of getting a number greater than 15? 5 out of 20. Minus. Now, who knows what I'm going to subtract? What number am I going to subtract? Tell me. No. How many numbers greater than 15 are even? Good job, girl. Good job. I didn't hear you. You're like to pretend like you're some little quiet little mouse. All right. And we all know that's definitely not true. All right. So that's the formula. Listen how simple that is. The probability of getting a multiple of 2 is what? 10 out of 20. What's the probability of getting a number greater than 15? 5 out of 20. How many numbers are greater than 15 and even? How many? 3. Now, can anybody tell me one last time before I reward you? Can anybody tell me why that's a 3?
It's over even and it's over 15 as that overlap. So
Yes, it's the ones that overlap, or Amaya, the ones that are what? No, you said a better word. The numbers that are repeated, right? The numbers that are both even and what? And greater than 15. All right. So tomorrow, guys, we will finish this. All right. I'm proud of you today, guys. That was a good job. Whenever you can. It's posted. It's on Google Classroom.